Okay, so here are all these possible states of thing one, and this is the probability of those states being selected. And which one are you going to get? F, right? That's the only one that has any probability. All these other states are zero. That's the case where you got up, you took a picture of your desk and the glasses were on it, right? Now you've got historical precedence. You can't violate that. You come back, where are the glasses going to be? They're going to be on your desk because it's data. Now what happens if you don't really know, you didn't take the picture, the data is kind of fuzzy. Instead of having a probability that's, in physics they call it a delta function. It's basically, it's like a infinitely thin peak. You have a probability like this. Well, they could be on a desk, or they could be on the couch, or they could be up in the bedroom. You see, there's different places they could be. And the way it works is you reach in randomly and grab a probability under a curve. Okay, so they may just end up someplace else. Now we're going to get to how this works in our life. One of the examples I like to use, because it's something that happened to me, is you come back from a trip, you've been gone for 2 weeks, you're really thirsty when you get off that airplane, dehydrated, you get home, you open the refrigerator door and you make a measurement. You're looking for the beer in your refrigerator. Okay, and you look and you know there were at least 3 or 4 beer in that refrigerator when you left. You remember that clearly, but there's not a darn beer in there right now. And what happened? Okay, let's say that if, like me, you got a guy who comes in and gives your dogs food and water and takes them for walks, you say, oh, that guy is, is drinking my beer. But if you don't and your house was locked up, you just don't really know what to make of that. I thought, sure, it was there. Okay, now again, if you took a picture of the beer in the refrigerator before you left and then you look at your picture, you'd have the same number there. That's that first peak, right? But if you don't, you may have 1, you may have 2, you may have 6, you may have none. It doesn't necessarily have to be what you remember, because your memory is kind of flaky and it doesn't really account for very strong data. Okay, let's go back a slide. All right, now, so you see the problem is, in an objective reality, we believe reality is objective. So we believe that whatever was in there when we left has to be there when we come back. And if it isn't, then it's because our memory failed. We're just wrong. It doesn't have to be that way. That could be the case. There's other things going on here. This reality is statistical and probabilistic. It is not an objective reality. That's just a scientific belief, is that we live in an objective reality. We do not. We live in a probabilistic reality. And physicists of all people should know that, because that's what the double slit experiment tells us. Particles don't exist. They're non-physical until you measure them. Everything in our world, all of the stuff that's our bodies and the seats we're sitting on, are all made up out of those particles. Right? So the thing that makes up all of the stuff that we say is objective is just probability distribution until you make the measurement. So we don't live in an objective reality. All right, so how do we get synchronicity? Well, you see, the system actively supports your evolution. So let's say you come in and there's no beer in the refrigerator. Well, the system can do that if it wants, because there wasn't any data that prohibited it from doing that. So you decide, because you're real thirsty, and you just get this idea in your head, I really want a beer. So you go down to the local neighborhood market, and while you're down at the market, let's say you run into somebody, just by chance, you run into somebody and they change your life. That's your soulmate. It's somebody invites you to their meditation club and you changes your life, or, et cetera, et cetera. And then we call this synchronicity. I just happened to run out of beer that I knew I had, so I go down here and I just happened to run into this individual, and then we just happened to talk about this, and this happened, and we see this synchronicity that leads us to opportunity to grow. Now, these synchronicities don't always happen to everybody. Who do they happen to? They happen to people who are able to make use of them. They happen to people who can grow from it. If you're in a mindset where all of that's totally impossible and ridiculous, then there's not a whole lot of educational value there for you. You see? So they happen more, and that's true of all these things. Deja vu, precognitive dreams, telepathy, prayer clearly being answered, voices of a dead relative over a phone or something like that. All these things that happen to people, for the most part, they're not about the information delivered. You get a you hear a voice or something, and the message is something like, "Hi, this is Uncle Fred." Well, that's not like exactly a super message. What's going on there is it's a personal experience just to open your mind. So the larger consciousness system can tweak the reality a little bit, because it's a statistical reality, to create things that just give you the opportunities you need if you're open to making something out of those opportunities. So that's how the system works. Let's see. The system just wants to nudge you, give you an opportunity. It's not trying to shove something down your throat. See, that's not how the system works. Okay, so think about it a minute. What does this concept do to the scientific method? You see, the scientific method depends upon objectivity. Okay? All experimenters doing the same experiment have to get the same answer all the time. Otherwise, the science is bogus. It's not real science. Somebody's made a big mistake. You see, the world isn't like that. The world is not objective. Reality is not objective. It's probabilistic and statistical. Objectivity becomes a special case of a larger understanding. Remember how we mentioned that? How the old kind of becomes a special case of a bigger picture? Well, objectivity, it turns out, is just a special case of a bigger picture. All right, let's go on to the backwards causality. Yeah, this one's also fun. Backwards causality actually doesn't ever happen. There is no such thing as backward causality. Causality always has to move forward. The effect has to be after the cause. Cause has to precede effect. Obvious, elementary logic, it has to be that way. But there were experiments done that made it seem as if causality could go backwards in time. And these experiments have been done many, many times by many different groups, some of them very high caliber science houses like Princeton University, Paralabs and that sort of thing. And they're repeatable, and they're all put in this category of backwards causality, or sometimes it's called retro causality. The first one that was done that I'm aware of had to do with people in a hospital, and it was in Israel, and it was a group of rabbis and others who used their focused intent in order to make people healthier. But now here are the circumstances. They got hospital records. Some of these records were decades old. These are people who have been out of hospital for 10, 15, 20 years. They got all these hospital records. And let's just imagine, this is not exactly how they did it, but I'd like to make the numbers simple and easy for us to compute in our head. So let's say that they had 20,000 of these patients over the last couple of decades. And they're going to break them into 20 groups of 1,000 each. Okay? Now, each group of 1,000, and when I say break them into, I mean randomly break them into. You randomly distribute into 20 groups. Then you take a group, one of those groups of 1,000, and you randomly break it into 2 groups of 500. Okay, and you do that then for each of these 20 groups. Now what they did then is they prayed and used their intent to make the experimental group, which is one of the groups of 500, healthier, feel better. And they used the other as just a control group. They didn't do anything to that group. They just let them be. Now what they found out is that they could actually shorten the hospital stay, the average hospital stay, for the group that they applied their intent to. And they shortened that hospital stay by an amount that's called statistically significant, which means the chance that it happened just on a fluke is about maybe 2 or 3%, 5%. Usually it's like a 90%, 95% statistic that you have to beat to be called statistically significant. So anyway, they did that. Now that's not that amazing, because strange things happen all the time, right? In 3 sigma events, maybe that doesn't mean much to you. Strange events, unusual events, improbable events happen all the time. But what was really amazing is that they did that in all 20 groups. And all 20 groups had shorter hospital stays than the control group. Now you've done something really amazing, right? That's like flipping a coin 20 times and getting 20 heads. Hard to do, about 1 in a million. And this is what happened. So this raised a big stir, and these things were repeated in many ways. The science guys get into it, and they did it more with technology. They had a Geiger counter, and 2 Geiger counters on either side of a radioactive source. Radioactive source now will decay in any random direction. So each of these Geiger counters over time should have about the same number of counts on them.